hydrogen to be able to power this rig. Now, before I bring Mike in, let me tell you a little bit more about it. It is powered by a Magnuson supercharged 6.2-liter LS-based engine, old school 5-speed manual transmission. It's got vintage air conditioning and much more. This is a high quality truck by any standard, but what we're going to focus on and talk about is the fact that it is powered with hydrogen. With that, Mike, thank you so much for joining Matt and I on the podcast today.
Oh, hi guys. I'm happy to do it.
All right, so take us right to the beginning. Where did it become on your radar screen? You're an engineer by trade, super smart guy. Matt and I learned that when we met you. Bring us into how hydrogen got on your radar screen and why.
Well, hydrogen has long been, known that it has some positives and some negatives, right? So the positives are that when you burn hydrogen, there's no emissions. The other positive is that there's more element to make hydrogen in the world than anything else. So those are all positives. The negative is it's somewhat limited in availability today, although that's changing every single day. So that was really the main negative. There's a misnomer out there. The Hindenburg had hydrogen in it, and a lot of people think that's why it exploded and crashed. And anybody that researches it will realize that was not the reason. They coated the outside of a cloth balloon and then hit a power line. And the coating they used, there were 8 different chemicals, and every one of them was flammable. So they actually caught on fire, a hole ruptured in it. The hydrogen all came out, and of course it burns when exposed to flame. But so there's a lot of misnomer about that. But looking at all of those things, that we knew that we could address and make a safe system and something that operates. So my hydrogen program started actually. I used to work at GM. I was an engineer at GM. I was at the end one of the lead engineers in the performance division, building all the one-off stuff. And throughout my career, I built the first ever. So if there was an idea or a new powertrain or a new suspension system, I would engineer those components into some form of vehicle that we could test and develop with. So throughout my GM career, at least for 25 years of that, Bosch was a big supplier to GM, and I worked with them a lot. Built some really strong relationships with them, and actually this whole hydrogen program started because one of the top guys at Bosch, and when I met him 25 years earlier, he was a worker like I was, and we ended up becoming friends, still are. He was retiring. They wanted to have a retirement kind of get together, and they wanted to come to my shop. I'd worked with a lot of engineers and everything through the years, and so we all met here at my shop, and I showed and did a tour for everybody, and then we were all just sitting around BSing, and the subject of hydrogen came up, and we were talking about it. They had interest and had some experience. I had a lot of interest, and the rest is kind of history.
So when did plans get underway for this 48 Chevy, Mike?
They didn't get serious until about a year before, about the November before the SEMA where we debuted the truck.
So November 2020.
Yes.
Okay.
Yep. And that was when we started, and obviously this is a new technology, and there's a lot to learn, and so we made some decisions on best practices, and I'm a hot rodder, right? So I have been my entire life, and so it was a natural for me to I own an engine build company. We went in and made a bunch of decisions, built the engine with a lot of additional safety features in it, and from that, I mean to make it stronger and make it hold up, because we didn't have a lot of knowledge in exactly what hydrogen would do when we put it in a supercharged V8.
Did you run this engine on a dyno, or have you done all your testing in the truck itself?
All of the testing on this specific engine has been done in the truck.
Oh, cool.
So we've run engines on the dyno, but they were different configurations and much, much smaller. And this is, as far as we know, in even any of the big engineering companies, this is the first time that we've ever supercharged an engine and put it on hydrogen.
So take us into the actual operation of the engine as far as power output, any unique characteristics. It sounds like you beefed up the engine just to be on the safe side to make sure that it was going to be plenty strong. What's it like to drive this thing and operate it? How different is it from gasoline powered?
It drives and operates just like gasoline. I mean, the only difference between the two from that standpoint is there's absolutely no smell. If you stand behind the truck, there's no carbon monoxide, there's no carbon dioxide, there's no hydrocarbons. It has no smell. And when you cold start it, you get just a little bit of like water mist that comes out of the tailpipes. And once the exhaust comes with temperature, there's nothing. It sounds like a gasoline engine. It drives like a gasoline engine. I mean, we've made great inroads with it, and we're just now running power numbers on it. And actually, probably tomorrow on Friday, we'll be running a big power test with it, and then I'll be kind of announcing to the world what the numbers are. We've already far exceeded anything anybody that's ever tried to do hydrogen before has made for a performance number.
So you guys have a lot more dialing in, and like you said, there's a lot more of news coming related to what you guys have already done. When you take a step back and you look at kind of the bigger picture, Mike, what's in store next for the evolution of this technology and the rollout?
Well, we've learned a lot, right? We've learned, mixtures, and we've learned engines. We've also learned that a lot of the things that I put into the engine for safety, from a standpoint of durability and that kind of stuff, aren't necessary. So we've learned that we can run a standard production gasoline engine on hydrogen with virtually no changes to the engine itself. So we've learned that. We've learned we can control engine temperatures with fuel mixtures. We've learned a tremendous amount. And to do the conversion, we run a tank in the bed of the truck that wasn't in it at SEMA. My tank was made in Canada, and customs impounded it for 5 weeks. They tried to come into the U.S. But, on the positive side, we could run the engine on welding tanks full of hydrogen. They make specific tanks designed for hydrogen, and we've used those. And so we now have the tank, and it's in the truck and all that. But, those were minor inconveniences. The system runs at 350 bar, so that's the pressure in the tank, which is like 5,074 psi. You have to run a special tank. Hydrogen is the lightest element known to man. So in a numeric numbering system that they've come up with for defining gas, the weight of a gaseous state, hydrogen is a number 2. There is not a number 1, but they left a space just in case we ever find anything lighter. The air around us that we breathe is a 34. So that defines how light hydrogen is in relationship to air. So that being the case, it's if you release hydrogen, it's going straight to the sky. You can't, if it's released, you can't stop it, right? You can shut it off and keep it from going, but that's it. It's also very, very small molecules that make it up. So it will permeate through, like for instance, a standard stainless steel fuel line that we would use in a hot rod. If you put hydrogen in that line, it will escape through the line.
Wow.
Actually through the stainless. So our tank is specifically designed to hold hydrogen. Our tank is DOT certified. We use electronic control valves on the ends that we control with the ECM for turning the hydrogen off and on. We have special lines, a military spec that was designed for some certain military applications. So they will not permeate. We regulate the hydrogen pressure down to about 8 bar, which is like 115 psi at the fuel rail. We run currently 16 fuel injectors. We run 8 in the traditional location, and then we machined an adapter that goes between the intercooler lid and the supercharger and added 8 more there. And we do that because all the parts that are out there right now for this are experimental, and they were never designed for a 6.2 V8. They were designed for like a 1.3 liter 3-cylinder engine. And so to get the volume we needed, we had to run 16 of them. So that's the basics of the system. We have a specific computer that Bosch manufactures. We operate in thresholds that traditional gasoline engines do not operate in. As an example, a traditional gasoline engine, the kind of accepted best performance number in a naturally aspirated state is 14.7 to 1 fuel ratio.
Right.
So that's 14.7 parts of air to 1 part of fuel. Our system operates in the 75 to 1 fuel range to 100 to 1. So we have to rewrite software and open parameters and do a lot of those things in the computer. And because Bosch owns it, they have access to all that. So it was very easy to do that. So, but that's kind of the story behind the components and how they function.
Based on the work that you've done, Mike, where do you see this playing out? Do you see widespread adoption of this technology? Will it be more isolated for kind of special projects, or do you see it becoming very mainstream?
Well, we're in the process. We'll very shortly here within the next 4 weeks or less, we will be running emission tests for CARB. So we're running those here in Michigan. Mall has a full emission test facility here, and we're going there to run the truck. And we're working with CARB, and our goal is to have a zero emission certification. So we know that's what it puts out. The only output is water out the tailpipes, and a very minimal amount of that. So we know that's the case. Once I get that certification, our goal is to take this as a conversion package. So we want to be able to retrofit, and we can retrofit any 4-stroke internal combustion gasoline engine to run on hydrogen. Our system will function on a weed whacker, a generator, a boat motor, anything, right? So lawnmowers could run on hydrogen. Any and all of it can. So this is a path to zero emission.
All right.
Okay?
All right. People are saying...
Our goal is retrofit kits.
Listeners are going to say, well, wait a minute. Toyota, Hyundai both currently have offered in the past hydrogen-powered vehicles. This is not cutting edge, but help us a minute understand the radical and complete difference. My understanding with the current production, there's only a few, as I mentioned, hydrogen-powered vehicles are not internal combustion. The hydrogen gets converted to electricity and runs electric motors. Is that a correct statement?
That is absolutely correct. So
okay.
Most of the vehicles that are out there today, and you're right, Honda, a couple Toyota builds one, Hyundai builds one.
Right.
Nissan has one.
Oh, okay.
They're in very limited availability, but they are fuel cell vehicles. In a fuel cell, there's a membrane inside the cell. You inject hydrogen into it. You burn the hydrogen inside the fuel cell. As it travels through this membrane, it generates electricity. And then that electricity is then stored in a battery pack and used to drive wheel motors, electric wheel motors. In our case, and that system is also very popular in a number of buses, right? And some commercial vehicles where they put a fuel cell in and electric motors. In our case, we physically inject the hydrogen into the port. It travels through the valve into the combustion chamber. It's compressed, lit with a traditional spark plug, traditional coil wire, and we ignite it just like you do gasoline, and then we travel it out the exhaust valve into the port and out the exhaust.
Incredible.
So same hydrogen can be used in both, but the process by which we extract the energy is different. Now, hydrogen, one of the things that people ask about is hydrogen, how do you produce it? And there are basically 3 ways that hydrogen is produced today. So the traditional way, which is considered somewhat dirty because it takes electricity and other things to do it, it has a carbon footprint.
Okay.
There is today what we call blue hydrogen. Blue hydrogen is manufactured with a much, much reduced carbon footprint. It uses some solar energies and things like that to produce it. It can be created, as I say, with a very, very small carbon footprint. There's also green hydrogen that's available today. Green hydrogen is manufactured with zero carbon footprint. Okay? So it can be manufactured. They use solar, they use wind, they use some other things to get the electricity part, but then it's the process is different by which it's manufactured. Fuel cell vehicles require a very clean hydrogen to operate properly. We don't require the same level, but that's what's commercially available. Okay? So we can use any of those processes, hydrogen manufactured in them. In the case of green hydrogen, we take hydrogen that's manufactured with zero carbon footprint. We put it in our vehicle. We extract the energy, create transportation with zero carbon footprint. There's no battery. The only battery in the truck is I have an Optima that starts it. Other than that, we don't use electric wheel motors. We don't use batteries to drive anything, none of that. So we have a completely from start to finish providing transportation, which is 100% without a carbon footprint.
Impressive. Current cost, that's probably going to change going forward, but current cost of hydrogen compared to gasoline.
So if I use pre-war numbers in California, because California is the only state where hydrogen is commercially sold in a pump, where you just drive up to the pump and fill your vehicle. Okay. There are stations, and I have one here in Michigan, but they're not just general public stations, okay? So I'll use California's numbers. Pre this latest war thing we have, 87 octane gasoline in California was about $5 a gallon. Okay. If I do the hydrogen, we buy by the kilogram, and that's how we use it. But if I do the conversion kilogram to gasoline and use the current number that was in California, hydrogen is about $3.50 a gallon.
Interesting.
So it's about a third less. The other interesting thing about hydrogen is in some of the stations, there were, when I debuted the truck, there were like 50 hydrogen public filling stations in California. Okay. They're in process to have in the next 18 to 24 months, 200 plus in California.
Yeah.
Wow.
Hydrogen can be manufactured on site. You don't have to manufacture it in a big facility somewhere and then transport it. You can manufacture hydrogen, pulling air in and subtracting the moisture from the air and create hydrogen with it.
So the gas station could, I'm using the word refine, maybe not the right word, but they can generate hydrogen on site. That's what you're saying?
Yes, and some of them in California do already. The one facility that we have near me here in Michigan, that's how they do it. They just use the moisture from the air and then generate hydrogen from it.
Wow. So, Mike, it's clear you are far from done with this initial truck. You mentioned you've got testing in the works. You've got lots of other development work happening. I think what I'm wondering is any other vehicle projects in the work, and maybe more importantly, when will people get a chance to see them?
Well, we're working on our SEMA 2022 build, and it will again be hydrogen powered, but it will be another advanced step in hydrogen. In where we go and what we do. If everything stays on track and where we're going, the goal is to debut this new vehicle there. It'll be in the Redline oil booth, just like my last truck was. Yep. If you don't know, Redline's owned by Phillips 66. So Phillips 66 has a huge interest in hydrogen. They're in the process of putting hydrogen is more popular in other countries than it is necessarily in the United States. So, but Phillips 66 is in the process of building 150 approximately hydrogen filling stations across Europe.